So welcome everyone. Thanks everyone for joining, the attendees and of course the speakers as well. So the third meeting this year of Commodore Users Europe. I used to say of Europe and beyond, of course, because we have now speakers coming from more or less everywhere in the world. That has always been the case, I think, since the first meeting we organized. Was it March last year or so? Yeah, so there will be again a meeting within 3 months, so that will be in December sometime. Yeah, before we start, maybe let me also tell you that I will be actually attending Amiga 37 event that will be in Germany next month. Don't ask me to pronounce the name of the village. It's something like Mönchengladbach or something like that. It's close to Düsseldorf, so it's nice, I think, nicely organized because it's not too far from Belgium, not too far from the Netherlands, Luxembourg. I think even from France, it's like 200 kilometers from Metz also, so people can attend more or less from everywhere. So if amongst the speakers or attendees today there are people willing to meet over there, don't hesitate, just send me a little message and we can meet real life. That's always nice to meet in real life, face to face, when that is possible. We have seen that in the last 2 years it was not so obvious anymore, so when we have the opportunity we should do so. So we have, again, like I just mentioned, several speakers coming from multiple geographies, I would say, today, with a nice agenda. We start with you, Jaime, so you're already on stage, on the scene, I would say. I guess we can start. Let me just start recording. So each of the talk will be recorded individually. So we'll start recording at the beginning and then at the end, so that it's easy to post later on our YouTube channel. And of course, so we are in Europe, so we have a regulation that is called GDPR. So for people who don't want to be in this video, then they should simply, well, we will record. So if you don't want to be recorded, you just need to leave, but you can still follow anonymously, I would say, from the Facebook page, because there it's also streamed live from there. So I will start recording and then record. There we are. Jaime, the floor is yours, and you will talk about, I have that here somewhere. Yes, of course, the Meatloaf and FujiNet for C64, please.
Sure. Okay. Hi, my name is Jaime. I am from the US, and this is a project I've been working on for a while. It's called Meatloaf, and it is a multi-device emulator for the Commodore 64. I'm also working with the FujiNet project to bring the Commodore functionality to their device. I actually started on Meatloaf about 6 or 8 months before I discovered FujiNet, and when they had posted a message in a Commodore Facebook group about wanting to port their device over to Commodore, I checked everything out and realized that I was already working on that. So I kind of joined forces with them to help make their device better and bring the Commodore 64 specific functionality to their device as well, and been helping to enhance that project. Let me switch over to my slides here. Let's see. So again, the Meatloaf device it's a multi-device emulator. It's very network centric as far as its functionality. It can take just about any file URL and convert it into an IEC data stream. That's the goal of this. Everything within Meatloaf is treated as a stream. So you give it a URL to a file, whether it's on your local flash file system or SD card, or if it's out on a web server somewhere, embedded in another, embedded in an archive, which also contains a container, and it just figures everything out. You give it the URL and it just returns a string that you can do whatever you want with it. In this case, we're feeding it in through the IEC serial port, and the 64 just thinks it's talking to a floppy drive. Let's see here. Let me go to the next slide. I'll go through that. Oh, yeah, this slide I was talking about, I was telling you about FujiNet some, and the differences between the two projects. Again, I had started things and then discovered what they were working on and wanting to port it over to the Commodore 64. So I joined in and offered to take care of that part. I am maintaining Meatloaf as a separate project just because I have some things in mind for it that are beyond the scope of what FujiNet is planning. And they've also gone multi-platform, whereas I'm planning to keep Meatloaf kind of Commodore specific. We are sharing code where it makes sense, and I think there's plenty of room for both projects. So let's see. Next slide. How Meatloaf is different than SD to IEC and Pi 1541 and some of the other devices that are out there. This is a question that I get a lot. What I'm trying to communicate is that it is not well, in relation to SD to IEC, Meatloaf actually emulates like a stack of 1541 drives. It's not just a single device. It can respond to any device ID on the IEC bus from 4 to 30, which opens it up to doing all kinds of cool stuff. I mean, you know, you can have multiple media on each device ID. So theoretically, we could have a virtual stack of 5,000 1541 drives. I mean, you can never connect that many drives to a single system, of course, but you know, virtually that is possible with what we're doing here. We also plan to have virtual printers. Thanks to FujiNet, they've already built a bunch of virtual printer drivers for emulating a lot of different printers with their fonts, and it spits out a PDF file right onto the SD card, so you can just pull it over your network connection. Meatloaf is not planned to be a cycle exact 1541. We are emulating a lot of the functionality of the 1541, but that was not one of the goals. I am doing some things, or I have some ideas that will make it more compatible so that demos and software that is expecting certain features of the 1541 to work properly. So I do have some ideas that could possibly make things more compatible for those programs. Let's see. Okay, so as far as loading data using the Meatloaf device, it does connect to the IEC serial port just like a standard floppy drive, 1541 floppy drive. So you can load data directly from the flash memory that's in the device. It also does have SD card support, so you can have a bunch of data stored on an SD card. So just like you would a SD to IEC or Pi 1541. We have also built or added a file format. It's just a .url file format, because you're limited on the amount of space that you have on the internal flash. Some of these modules, these ESP modules, only have about 4 megs of flash memory. And if you want to access a lot of stuff, or at least have quick references to a lot of files, we can do this through these little URL files. So instead of having to type out a big long URL, you can save it into a file with a .url extension, and the Meatloaf device will read that file and then redirect to the URL that's in the file on the system and go out over the internet to grab that data. The Meatloaf also supports loading directly from a URL using just a standard load command. And I'll demonstrate this in just a few moments after we get through the slides here. Actually, I can show you that. I can switch over to that and show you that. Let's do that right now. So I'm going to switch over to my HDMI view. This is a live feed directly from my 64 that's sitting right here. I'm going to reset. Let's just reset. And I'm going to type in a URL. C64. And we're going to load game of the day. This going to come directly off of server out on the net. So HTTP, make sure I got everything typed correctly. CC. Okay, I'm going to hit enter. Actually, I'm going to switch the view so you can see on this left-hand side, that is a monitor view, monitoring the serial output from the device. Oops, sorry. Monitoring the serial output from the device so that we can see it communicating with the server. So I'm going to hit return. There we go. It's establishing an HTTP connection, and it is loading, streaming that data directly from a server on the internet into the memory of the 64. Of course, it is standard IEC serial speeds, so it is loading slow. I do have plans to support fast loaders and Jiffy DOS, as well as parallel transfer through user port, and that's going to require an extra connection from the device, so it'll connect to the user port and to the IEC serial port, but it'll give us much faster loading times. So there we go. We've got that loaded, and let's just run and see what our game of the day is from the server. There we go. Loaded up right over the internet. I'm going to reset that. And I want to show you, let's switch back to the slide. So that was the direct URL loading. The next way to load files from a URL is I've set up some scripts on the server to support a shortcode system so that you can load things without having to type a big long URL. Possibly a URL that might include special characters that you might not necessarily be able to type on the Commodore 64 keyboard itself. So I've created this script to solve that problem. Each shortcode starts with ML:, which is short for Meatloaf, and it hits the meatloaf.cc server, does a lookup on that code, and then returns a URL, which the Meatloaf device then directly connects to that server out on the internet and loads the program. So let me show you that real quick. Let's see. I'm going to go back to the VS Code Zoom mode here, and I have a shortcode set up for Mind is Born, the demo. So I'm sure you guys are familiar with that. It's a little 256 byte demo. It's really awesome. Let's see, let's load that. Establishes HTTP connection. It's the URL, loads the data, and we are ready to run. There it is. I don't know if you guys can hear the sound or not. But quick little way to load stuff. I've also got some scripts set up on this server using the shortcodes that allow you to load, say, a random game. And the great thing about this is the shortcodes can be configured to hit any other server. And I'm gonna be adding scripts on at the meatloaf.cc website so that people can register their own shortcodes and redirect. You know, they can use the shortcodes to use the Meatloaf device to redirect to their server and load whatever they're sharing for everyone out on the internet. I'm gonna show this other script real quick, or this other shortcode. Code game star. And what this one does is it hits a script. Oops, I did not put it in that window. No, there we go. What this one does is it hits the script on the server, selects a random PRG file from a directory on the server, and then sends that URL back to Meatloaf to load directly. Let's see what it loads a random game every time, so you never know what you're going to get with this script. It's just a demo to show some of the kinds of things that we can do with this network functionality. That is loading. Of course, it will be nicer once I get some fast loaders and stuff working. A little bit better. Getting close, 70%. Almost there. It's kind of cool. I like watching this data stream. It's actually showing you the address in memory where the data is being stored in the 64 as it's loading. This, of course, is just a development feature while I'm debugging and testing and whatnot. So let's see what it loaded up. Run. Yeah. So what is this? Can't read that. So anyway, it loaded a random game from the server. All right, I want to back to the slides. There's one more way that we can load data into the system using Meatloaf. Again, this also solves the problem of having to type out a long URL. And what I did is I wrote a browser add-on. It's called Send to Meatloaf. It's available for Firefox, Chrome, Opera, Safari, Microsoft Edge. I ported it to all the different browsers and got it into all of the different add-on web stores. So what you do, I'm going to switch over to the browser mode. So the idea is, say you're out on the internet and you are browsing for CSDB. I already had it on the demo that I was going to load here. But say you're out browsing the web and you find a link to a PRG file. Right now it's only supporting PRG files, but we're very, very close to having it working with D64 images and D81, all of the different media file formats. You'll be able to mount them over HTTP and load them like you just pop the disk right in the system. But at the moment, it is just loading PRG files. So say you're browsing CSDB, you want to load up something that you see with your Meatloaf device directly on your Commodore 64. I'm going to select the Love Cats demo because it's kind of cool. And you just scroll up, you find the image or the PRG file. Right now, PRG file. I'm going to right click on this. And I know this is hard to see, but you just select Send to Meatloaf. I click that, and then it pops open. Oh, it popped up on my other screen. Let me move this over here. It pops open a little window that tells you that the URL is queued up and gives you the command to use on your 64 to load the program. So let's switch our view back to VS Code here. We're going to type in that command. Star. And hit enter. It's going to establish that, or it's going to grab that URL from the server and then go out to CSDB and download that directly. And we'll be running it. It makes it really easy for loading anything that you find out on the web, not just on CSDB, of course, but any link that you can find out on the internet. This it also works with just plain text. So if the text is on the screen in your browser and it's not a clickable link, you can highlight the text, right click, and select send to Meatloaf, and it will queue it up at meatloaf.cc to be proxied to your Meatloaf device to be loaded up. Also, I am planning to have it set, and I haven't tested this yet, but being able to select text off a page, if there's a basic program listing, you'll be able to highlight that text, right click on it, and send that to Meatloaf as well. And it'll tokenize it and have it ready to load right into your device. So you don't have to retype some of these old programs from magazines and whatnot if they're available in a text format out on the web. So okay, that loaded up. Let's run. And switch to our HDMI only mode. And there you go. We have our demo up and running. So, all right, let's reset that. And go back to our slides here. Next slide. Okay, so those are all the different ways that you can load different things using the Meatloaf device. The URLs to target the file, it can go through multiple protocols, different file formats or container files, and the beauty of this code is that you don't have to do anything special. You just feed it a URL, and it gives the device back a stream that it can feed to the Commodore 64. I have to thank one of the guys working on the project. I know I'm gonna mess his name up because it's Polish and I don't I'm trying to pronounce it correctly, but I believe it's Jaime is his name. He is responsible for creating the classes for doing all of this magic with the full URL and just giving us back a nice stream that we can work with. So as you can see, I know this is probably a little small on your side, but you just feed it the URL. It can have a zip file in the URL, and then you can target a D64 inside of that, and then your file inside of the D64 container that you're actually trying to load. And you just feed that through a load command in BASIC, and it does all the magic and returns it to you. So some pretty cool stuff. I mean, I'm loving working on this project, making this stuff happen. We are planning to support just about every file media format that has ever been created for the 64. Right now, we're of course supporting D64, D71, D80, 81, and 82, T64, T-cart files. I'm treating them just like a disk file, so you can mount it and do a directory listing and load any of the files out of the TCRT file. I have several others that aren't listed here that are supported, some non-standard formats, the D8B backbit file format, and a few others, but the plan is to be able to load anything that was ever created for the system by plugging in this one device and just having access to everything out on the internet, you know. Another feature of the device is that it can translate PETSCII to and from UTF-8 on the fly. So say you're loading HTML directly, it can detect that and convert it to PETSCII so it looks, you know, somewhat better on the 64 screen. Same thing with text files. When you load and save text files, it'll to the flash storage or eventually to HTTP and other protocols. It will do that UTF-8 translation on the fly, so you don't have to worry about it. Let's see, the next slide. Oh, upcoming features. I talked about this a little bit. It's going to support fast loaders. It's going to support Jiffy DOS. I've already been working on parallel loader support through the user port to support speed DOF, and DOS, and others. I am planning to also support the WIC64 application. It has its own API for programming or for accessing the device, and with the parallel interface, there's no reason why we can't support those applications as well. I've been in contact with Kiwi, and I'm also going to take some of the Meatloaf code and add that to the WIC64 project. I'm going to work with him that will give the WIC64 project the ability to work with D64 files and all the different file formats as well. So I will share some of that code with the WIC64 project as well. He's already sent me the latest code that he's been working on, and I've actually taken it and broken it down into all of the individual components, so that instead of being one big Arduino file with all the code in there, it's a little bit easier to get around in it. And I'm hoping that will help with the project as well. So let's see. I think that is the last of my slides, and I don't have anything else to demo right now, but looking forward to getting some of these other features completed. And also, the reason for presenting this is to get others interested that might be able to help with the project. It's all open source, all the hardware, software, everything. Right now, if you want to build a Meatloaf device, you just need an ESP32 module, a little bit of wire, and a DIN6 plug to build the very bare minimum version of the hardware. So it's really easy to put together, about $10 or so worth of parts, and using the development firmware right now, you can get up and going and start playing with some of these features and exploring the possibilities of what it can do. You know, I'm sure there's a lot of things that I have not thought of that others will, that this thing will be able to make happen for us. So I think that is about it. If anyone has any questions.
Thanks very much. It's really, really nice. I've seen the comments, everybody saying, yes, awesome, really nice. I really like this, the fact that you have this, you said it's a debug functionality, but that you can monitor what is currently ongoing, the exchange of data. At least you know that your connection is on, right?
Yes. Yeah. I have added an LED library to the code so that we could, I want to put some LEDs across the device, so that at least 5 LEDs, those will be the 5 pixels in the Meatloaf icon, and we'll load them up for 20% of the loading of the file, especially if you're loading a big file. But I suspect also that whenever we get the fast loader support working and the parallel loader support working, the wait time's not going to be as significant as as it is now. So.
Yeah. Good. I don't know if there are questions. I have one, by the way. So you mentioned the different protocols. You showed as well that it's translating from UTF-8 to PETSCII. What if you'd like to open a BBS? Then you need a terminal. Will that open a terminal by itself, or is there a shortcut possible is it possible to create a kind of shortcut so that if I telnet into something, it will first load a terminal and then start loading the content from there, or is that absolutely nothing to?
I would have to explore that. I would imagine you would load a terminal first before you start connecting to a VDS. And I was also envisioning, say, a driver for making it work with, say, CCGMS or some of the other terminal programs that are out there, because initially I did want it to talk serially through the user port. And I do have some ideas for the circuit design to switch it from parallel mode to serial mode so that it could be used like a standard Commodore modem. So that is a possibility if I can work out the circuitry to make it do that. But loading over parallel and having a parallel driver that works with CCGMS would be ideal, because then you could, it'd be a lot faster. You could simulate any speed you want, really.
The question popped up to my mind when you showed this this extension that you have for the browser, because sometimes you have like these inventories of BBS, so it would be nice if you're there browsing and then you say, yes, this one I would like to open.
Yeah, and have it kind of chain load a terminal program. That is possible. I was looking at creating chain loaders for SID files and qual files and whatnot, so that if you go to load a .SID, it first loads a player and then chain loads the SID into memory along with it, and then you could load it directly without having to load a player first. So that could be a possibility for terminals as well. I like that idea.
Nice.
Well,
Thanks.
I was curious, Jamie, with retrieving the files from a HTTP address. I was curious, did you have like an option to get a directory listing? Like a load $, $1 sort of equivalent.
Actually, I can show you. Let's try that. I think I have that working with I showed you the loading the random game. Let's see. Let's switch back to the HDMI mode. There we go. And let's do load. I'm using shortcuts now. Load now. That one. I actually wrote some PHP scripts that will return a standard PRG file to a Commodore 64 using directory listing from a server, and that's what I'm using here. So load, and there we go. Oh,
Marcel.
Game $. That should have worked. So, let me reset the device.
¿Me escuchas vos o me escuchan todos?
There we go. Loading. Kind of loaded something there. I have to check this script because what's this? There we go. That loaded from the server.
Okay, cool. All right, nice.
It loaded the default folder. So let's see. Yeah, it did load from the server. If you check my GitHub, I've got some scripts there, some PHP script. Well, not it's gist. So gist.github.com/idolpx, and I've got a gist there for it's a PHP script. You point it to a directory on your web server, and it will return an index.prg file that can be loaded directly into Meatloaf, and it gives you a directory listing of what's in that folder on the server.
Cool, very nice. Cheers.
Yeah. Let's see. There's my webcam again. Okay.
Really nice, thank you. I don't know if there are any other questions. Wilfried?
Yes, thank you for the great presentation. So what I understood, basically you have a native C64 because everything, the added intelligence is basically on the device that's hooked up to the IC port.
Yes.
And for your presentation, I think the image was quite crisp, so probably you used an emulator, right? So my question would be, is it possible to connect an emulator to the Meatloaf as well?
I would like to add emulator support, but what you were seeing there was a video capture from an actual Commodore 64. Everything that I presented today was working directly on a real Commodore 64. I could actually let me show you. It's on. I'm working off of my dining room table right now. It is the 64 right there. It is a real 64 that I was demoing.
We have nice video capturing.
Like it's the I'm using the Shadowcast device and a little it's an AV to HDMI converter. So I connect the 64 to the AV to HDMI converter, and then I plug the Shadowcast into that, and then I'm doing the capture with OBS on my MacBook.
Nice setup, yeah. But for example, for cross development, of course, emulator support would be nice.
Yes, yes. And I have been looking at adding a virtual Meatloaf device in Vice. I see that there is a little bit of support for WIC64, and I know kernel 64 supports WIC64, a WIC64 virtual device. I don't know enough about how the virtual devices work, but I agree. It would be awesome to have it there as well.
Cool, thank you.
Yeah.
Hey, question. Yeah. I got a question. Will it support ANSI terminal?
That would support ANSI terminal?
Like old age, like almost like 90s BBS, ANSI, ANSI, ANSI.
ANSI. What would this support it?
No, what would it support it?
If someone wants to write the filter for doing the translation, it should, yeah.
Okay, awesome. Thank you.
Yeah, the way we've set the system up, we can have filters for any stream. So again, everything within Meatloaf is a stream. It opens the URL and returns a stream, and then you can feed that stream into another filter that translates it. That's how we're doing the PETSCII to UTF-8 translation.
Awesome. Well, thank you.
Yeah.
Thanks. I see still one question from Daniel.
Okay.
Yeah, I was wondering, like games that use levels or something like that, which are loaded, are currently not supported, right? But wouldn't it be possible to, let's say, define some kind of a URL pattern or something like that that says that everything from now on shall be loaded from the same address?
Yes, it does. It does set a base address whenever you load from a URL. Mm-hmm. So any file loaded next would be pulled from that address.
Okay.
So you could do a load, and it does support just the standard CD, commands. So actually, let me show you. It's not working over HTTP at the moment. I have to finish that support. But let me show you. Say right here. Let's browse the flash memory. Say load. I'm going to set it back to root. You can do CD commands through a load command, and it does the change directory and then sends you back a directory listing. So load CD / that sends us back to root, and we list our directory. And say we want to go into the SD card. We can type load SD. It's going to detect that as a directory and automatically change directory rather than trying to load it as a file. So we get that, and now we're in our SD card directory. Again, it also works with. Let me do this. I'm going to load. We're going to load from root the file browser 64 FP64. It's loading. And time. Yeah, we're already. I enhanced the directory listing. I don't know if you noticed that at the top. It shows you what path you're in. It'll also show you what URL you're connected to, and what your current URL is, what your path is on that URL, and if an image or archive is mounted, it shows that at the directory at the top of your directory listing. Right now, it's just showing the path, which is SD because we're in the SD card. I'm going to go down, and there's a .bit folder here. This is kind of cool. Let me switch to the VS Code view so you can see the data streaming in as I browse through here. I'm going to go down to, let's go down to view. You see our directory streaming in. And then let's do Ultima 3, D81 file. It's going to load the directory listing first. There we go. You see our path there, /sd/bb/u. We've got our image mounted, showing the D81. And then below that, these are all the files that are actually in that D81 image. I'm going to hit enter here. And it's going to start streaming the data in and loading it from the Meatloaf device. And we're loading Ultima 3. It's kind of cool. I love watching this data stream. The first time I got this working, it was really exciting. I've enhanced it some. It really doesn't add any functionality other than just being able to visualize what's happening. There we go. And we're loading Ultima 3. And I've got some issues that we're working out with the HTTP protocol. We can get a directory listing from an image on a server right now, but for some reason I kind of know what's going on. It's jumping around inside of a disk image on the server. We're using range headers, HTTP range headers, to jump around inside that disk image to get at the data. And there's something that I'm not doing quite right, so it's really slow, and then it just fails. But I'm very close to having that completed, and then we'll be able to load these images right from a web server. Actual D64, D81 images. We'll be able to mount them right from a URL and access them just as if they were popped into a 1541 or 1581 drive directly connected to the system. There we go. Loading all the files. This is almost loaded.
Yeah.
Yeah.
I think just Jaime, we will not take any more questions. I guess if people have more questions, they can put it in the chat, because time is running. We have other people following as well. Thanks a lot. I will stop the recording now.
All right. Thank you, guys.
Thanks a lot. And again, if there are more questions coming up, people can put it in the chat, and then you can still reply it from there. So now we'll call Marcelo as the next coming up with the RGB to HDMI converter. So if you like, Marcelo, then you can start sharing your screen or your video, but the floor is yours. And I will start recording now.
Okay, can you see the screen?
I can see your screen, yes.
Excellent. So let me just introduce myself. I'm Marcelo Lorenzati. I'm not Italian. I'm from Argentina. So I'm an electronic engineer from, I don't know, since quite a long. I'm 48 years old. So for me, when we talk about retro computers, and especially from Commodore, for me, it's not only about the fond memories. It's how about they pave the future for multiple, I would say, professionals and engineers that have been working with this marvelous, I don't know, nice computer. And one thing that is important for me is that the door that opened for the people, as you know, prior to the Commodores, there were no computer for the masses. So, and it's also something really interesting that the Commodore computer were open in their architecture, so you could interface through their ports and investigate and do really cool things that now maybe with devices such as Raspberry Pi is something that we think is usual, but in the 80s that was really something really cool. And also now in the present, it's really nice to be able to be in contact with people really cool people that know a lot about technology, and it's just a door opener for talking with the great people with a great knowledge. So when I started to work again with this Commodore computer, for me is the opportunity to talk and meet a lot of cool guys and people on the industry. So I hope that continues to be in that way. So now I'm going to be talking about what I have built, which is the Pico RGB to HDMI. I know there are other converters in the field that maybe with the same name. So that's why it uses the Pico as the initial name. So let's go a little bit on what is the agenda. So I'm going to be talking about why I did that, a little bit about the architecture that I included there, some of the features that it has, some maybe also some of the future things that I plan to add, a demo, a space for your questions, and any final thoughts that we could have. So as you can see here, this is an application that you can use. I mean, it's really raw application in Python just to prove that you can interface with the board. And let's continue. So as you know, past the initial 80 computers, like the Commodore that were using composite or super video images, another standard appeared, not I would say straight hard standard, but it appeared, the RGB, which was an evolution of the TV video TV. And as you know, what they did is just to separate the three signals from the originating computer and use separated or maybe composite synchronism in order to be able to place the image into the screen. So one of the things was the limitation on the kilohertz for the swipe, for horizontal swipe, or on the syncing. Usually we're below the 31 kilohertz, which is the limit where you are going to be seeing what is the VGA standard. So the usual was 15 kilohertz. That was what it was used for the NTSC and PAL video formats. You can see a little bit more about the timings on those monitors in that page and in that link that I shared there. And the usual interface that you are going to be seeing for the RGB is the SCART connector. But if you know your computers, your regular computer, you will see that there is no standard regarding the connector itself. There's a plethora of a type of connector. If you have an ST, if you have a Spectrum Plus, or if you have an Amiga computer, is different, the type of the connector, but the signals are, I would say, similar. So this is just a quick view of what I was mentioning. So you have a vertical back port and a vertical front port. That is the time that the system, the rendering, or the computer that is emitting the signal will make a space for preparing the beam. We are talking about the times that we were using CRTs. And you have the horizontal back port and front port. That is the preparation when you have the horizontal sweep with the information from the pixels. And well, basically this is just a representation, and if you can see on the left, you will see the same that I'm referring on the right, but with signals. The additional thing is that there is no standard regarding the timing. So depending on the computer, you are going to be seeing that the horizontal back port is maybe smaller or higher, and you will need to adjust in your old CRT. Maybe newer monitor will be able to sync or to make the auto alignment of the image. But as I said, there is no standard in the timings. Either if they do overscan, so they use additional lines. Maybe they are stepping in what could be considered the verticals front and back porch. Some computers draw lines there, so sometimes you need to adjust also the vertical to fit all the information that you are receiving from the computer. So as I said, no strict standard, a lot of variation, and let's continue. What is the problem? So as you know, they are not getting handed, or you're not going to be seeing a lot of CRT monitors that are capable to show this type of images. They are getting old, or they got broken, and some monitors, some professional monitors that you may get, they are really expensive. So the one that we're using in the TV industry, but there are options to connect with a newer screen, the computers. So you have the open source, I don't remember the other, the scan converter. But the problem is really high, the price, basically because the thing with the hardware is that they are using a real powerful FPGA inside of it, and that elevates the cost, but it's a really good choice if you're looking for great image. And most importantly, if you're playing games in these old computers, you want to have real short response times. So if you process images and then you render on the screen, you're going to notice the latency. So that is the problem of the second type of converter, the one you can get from Amazon, so the SCAR converter. And the problem is that those converters are just tiny microcomputers with the HDMI head, and they just capture the image, they process it to show it in the resolution that you want. And the first problem is that they just destroy the original image. You see artifacts of this of the subsampling or the upsampling that you have there, and also a lot of latency, maybe above the 200 milliseconds, something that is not noticeable. And then there are newer options like the Pi0 based RGB to HDMI that is really good. The thing that I see on that solution is that they are using a Raspberry Pi Zeros, which tend to be now a little bit expensive and an overkill to have just a full computer just to render another computer. So also the complexity of the sandwich of boards that you have, I mean they call it hats. So they get a little bit complex, and right now the limitation are 12 bits for the resolution. So cost and complexity. And then the other one that are, in my opinion, I don't like to touch it, the computers that just to get it working, and I don't like it to put things inside. So when you put solutions like the Amiga Digital Video, so you are interfacing directly with the I believe it was a Paula for the video. I always confuse it, but basically you're just reading the video digital output from the 12 bits video, and you are transforming it. So I see it as a little bit invasive, but it's a cool option too. Also expensive because you're using a Pi0 and the board that you need there. So those are the options that I saw on that you can have, and I say, why not another one? So as I said, FPGA. This is by the way, a really cool board. It's an open source project for having a development board with an FPGA, which is called iZoom. But as I said, you need to synthesize everything, and you need a lot of memory to host the image. As you know, if the computer that you are capturing the image differs of the sampling rate of the monitor, so if you are using HDMI, the usual is 30 frames per second, 60 or can be 60 hertz refresh rate. So if the image is 50, you need to host all the image to be able to render it into the HDMI. So that means a lot of memory. If you can imagine, by height with the density of the colors that you want to use. And the other problem is the frequency for the capturing, because you're going to be using an SDC converter, and you need to clock that converter in order to capture the image. So imagine it's the usual, if you're using 12 clocks per pixel to capture the information, that's around in the 12 samples per second to have a 6040 by 240 image. That means 144 megahertz. That's not a low frequency for a computer, for a microcontroller. So those are the challenges, as I said, with an FPGA. I was thinking, what about using another thing? So there are powerful microcontrollers that you can use in the market with different, I mean, you have microprocessors that host on die an FPGA, so it would be almost the same. But I thought it was a really neat implementations that the Raspberry Pi Foundation did with the RP2040. Besides having a dual core M0 processor, which is not quite outstanding, it's just the basic ARM processor that you can have now on microcontrollers. What I thought that it was really cool is the PIO, the programmable I/O, which is, well, it has two PIOs, this microcontroller, and it can run any kind of program that will interface with the pins, with the I/Os of the board. So it was thought as a way to interface any kind of protocol, hardware protocol of a chip that you have. You can code it inside the PIO. The PIO has several state machines that will run its own code, and it will run completely standalone from the main core, from the microprocessor of the board, and it is cycle perfect. So anything that you place on that code, it will loop and it will run perfectly without variations. And the other part that is important is that you can connect it with the DMA just to make fast transfer with the IRQs. So it will transform in a full-fledged peripheral of the board. So if you want, you can build, I don't know, another USB inside the board that has an USB. So that's an idea. So I say, oh, let's try what we can do with this. So this is basically the idea behind of what I built. I say, if we are able to capture the RGB signals and we synchronize with the horizontal and vertical information from syncing, and if we properly configure from the RP2040 the offset and the gain of the image, and so you are going to be able to capture each one of the pixels, like the red, the green, and blue, and you can transport that information in real time, building a program, a really tiny program that is completely outside of the control of the main program, that captures that schema and take it into the video RAM. So that is the first step. You can capture information, you sync with use the horizontal sync to say when you want to start capturing, you have in mind the front port from the image, and you start capturing the pixels and place it into the RAM buffer, and then you prepare for the next one, and so on. Then you count the lines into, you have a full frame of the image using the vertical sync. You can count the lines, you can do all the math, and basically that what is the proposal here. So you can capture all the image and you can render back using another thing. So the cool thing here is that you can either use an implementation for VGA that the Raspberry Pi Foundation did. So if you like VGA, you can use it. There's as part of the examples that the code has, you can implement VGA, but it uses a lot of pins because it does an R2R digital to analog conversion. So I say, why not? We can use an HDMI implementation to go to the screen. So I have to add it here. I think I will. It's on another slide, but basically I used an implementation of a guy called Bren 1991, I believe, with the whole implementation of the DVI protocol, which is the time minimal domain. Well, I don't remember the TMDS. It's not time multiplication. It's the way that the bits are being sent from the chipset into the HDMI. Basically, you have red, green, and blue, and clocking, and each one of that has 10-bit wide for the data that you send. That they are control bits, and it manages the parity because those each one of those lines are differentials. So that's the full idea of HDMI, to reduce the noise and the eye pattern when you transfer information. And basically that's what I did. I just hook that implementation from HDMI and captures the information from a video RAM that I did, and I just whatever I capture from the RGB, I put it on the video RAM, and then another core is rendered on the information back to the HDMI. They use it a lot of micro programs with the PIO, and yeah, and then there are a lot of sublayers of code to manage DMA transmission, interruption, in order to detect when the horizontal syncing happens and start to capture, and well, the application that gives a sense of all the solution. So. No, I also, as I said, it has USB capabilities, and the RP2040 has those capabilities, so you can implement using tiny USB the CDC serial protocol, so you can interface. And as I said, I did a small application to test it. This is just a high-level view of the stack. So you have the DAC PO, so there's a lot of micro programs to run on the inner layers. Then you have the usage of the peripheral SDK and some libraries to manage the scanning of the RGB, the DVI, video RAM usage, keyboard. I have a parser for the USB command, so you can, if you are fond to use a command line, you can use it from there. And then I am completing, well, I have a video overlay. So you can place on top of your image, you can place information. And now I'm working on a graphical user interface, a signal slot based kind of a graphical user interface, so you can configure it. Right now, I'm not using it in this demo. And well, a new system to do the same things that you can do by commands, you can do it by the GIMP. So let's go. As I said, modes from the HDMI from 640 to by 480 up to 1280 to by 720, which is HD kind of images. But the limitation right now is the capture mode. So you have 320 by 240 with 16-bit colors, so limitation memory. And I implemented a 640 by 240 8-bit color mode that well, uses less memory, but you reduce the color density. And it was really interesting how you can use, as I said, 144 megahertz clocking. So you capture RGB colors in 8-bit. Each one, well, it has 24 color depth. So you just shift the bits into a word, you reduce the density that you want in order to do, I don't know, 565 color coding or 332 color coding, and then you shift it back for the on a FIFO onto the DMA, and you put it on the RAM buffer. That in real time. So that's the awesome. I never thought that it would work, but it worked. So well, it has some keywords. The overlay that basically I just chop one piece of the rendering, and I just play the image there. Myself, I just tested on these computers, the 128, the Amiga 500, the 1200, and the Atari ST 520. But a group of guys that are helping me with the testing are going to be testing with the other microcomputers like the Spectrum, or they're using some Macs also. Well, that's the link from the to have an overall view of what I did. And let me just reduce this. Let me know if you can see here. This is my view, and this is, let me show, this is the board. This is the alpha board. Oh, it's not focusing. This is the alpha board. I am waiting for the beta board to come with some improvements on how we interface the image from the microcomputer into the ADC, basically because of the impedance adapting, and also because each one of the computers behaves differently. So I just added a buffer. As you can see, you have there that tiny chip is just it's called AFE, which is an analog front end. It's a small sensor that is used for the cameras, for the CCD cameras, as an example. And you have just a Raspberry Pi, really cheap. So as I said, $4 you can get this chip. This Raspberry Pi is just $4. With board and everything else, is not really expensive. Right now, it's not open. I plan to open the hardware for do it yourself, and then ultimately in the last part, when I feel confident that the system is working okay, I'm going to open the source code too. That's the idea, the original plan. And as you can see on this screen, this is what is being rendered from the Commodore 124. So let me just have it here, and let's just run. I had to run or to build. So that's just to show some colors. As you can imagine, if I just reset the computer, you see that it's shifted the image to one side. That is because of the timing of this computer is different with the other, and I just I don't have auto correction of the image. So right now what I have is this tiny, let me just put this on top, these tiny buttons. So the idea here is that I can just move the image from one side to the other. Let me just put this here. So the idea is that you can move it and correct the image right now, but in the future I plan to, where is it? I think I just keep it. And there you go. Okay, as you can see, that's an overlay that I can do on screen. There, well, as you saw, it didn't impact in the image, so I can just move it. But the problem is the board is completely well, naked without the housing. So if I touch something, it's not really behaving well, and that's it. So I can, as you can see here, this is doing just an adaptation from RGBI, which is digital levels, into analog levels. So this board can adapted. And now the plan would be to connect it to the Amiga, which I have there. Let's see what happens. Okay, there it is. So it's connected. And as I said, I adapted the syncing to show this properly. Same thing, you can it's rendering with 8-bit color density. I can change. You can see. I don't know what else I have here on this computer. Oh, there. So if you know the Amiga tester, you will know that those colors are shifted. That's because of the limitation of the colors. Let's just use F6. Let's see the gradients. So as you can see there are some noises. That's the things regarding the adaptation. But the stability is really good. And well, you can see that with this simple, I don't know, construction, you can have a good screen for the Amiga. One thing that I would like to have that is really complex is to multiplex the audio. I am investigating that, and I think it's going to be a little bit complex. And the other part I want to share is the capability to communicate with by USB. I have to do something which is to enable the USB because it produces glitches. Basically, because I need to understand how TinyUSB works. It's a little bit invasive on the timing on the system, so I should have to enable it by pressing the 3 buttons. There you go. And if you pay attention, there might be some glitches on the screen, like some tearing, some lines that you see that gets broken. But now I can connect it here. It should detect the application. Let's see. I think it's not enabled. Let me see. Okay. There you go. Okay, it detected the device. You have some console here. So as I said, you can use it by command line. So now a lot more visible the errors on the screen. Let's just send some commands to move the screen. There you go. So you can do it from here. And let's, I mean, the neat thing is about capture the image. So it will just freeze for a sec and it will process. So Python with USB, with the serial is not really good, but that's why it takes some time. But as you can see, we can capture the image. Let's put something else on the screen. I don't know what else I can show, something more interesting. And if you have question in between and you want to shoot it while I load something else, just go. Let's see. I don't remember what does this dotted has on. Okay, this is the. Let's put another one. This is the gallery. Let's see. Okay, loading. So as I said, right now is on this stage. When newer microprocessors from the RP20 or no, I don't know which family from Raspberry Pico will appear that will allow me to introduce more color density, more resolution, and more speed to be able to properly manage the timings. But right now it's in a beta way state. I just choose one game without that it requires a shot stick. Let's put another one. Oh, Lotus Turbo Challenge. I hope I have a sound on this one because it's really nice. And let's wait for something to capture on the screen. Okay. I think that was a reset. Oh, it resetted the board. There you go. Okay. Now, I just forgot to add the joystick. Okay. Any questions? Something that you want to know in between? I just do this.
Let's see if it loads in the background. But thanks a lot, Marcelo. It's really nice. I think we have all tried many options. Like I had one of these card converters, so it was not that good, and it was quite expensive, I must say. I saw as well this Raspberry Pi possibility. There are multiple projects that are documented online, and you can use that with these hats. But then also just building it is indeed quite a complex situation. Well, a complex solution for what you want to achieve. But when I see this platform, what you have, let's say, all the package that you have compiled there from that you have built, to me it sounds like it could be used really as a kind of platform to do, I don't know, multiple other things like not only capturing but maybe more video data acquisition or something like that. Will you document all that? Will that be published on your website, or is it already documented somehow?
I created a documentation, yes, of the usage, but as we say, this is the cool thing is that you have like I don't know, 20 bucks or something like that, 30 bucks microcomputer with HDMI and three channels ADC. That's the thing I think is really cool. So you can, I mean, you could do an oscilloscope, a 3-channel oscilloscope. It's around 24 megasamples per sec, the capability of the ADC. So that makes it really powerful for other options that you want to do. And of course, we can extend it. That's the thing. I'm trying to, let me just reset this to enable another capture. I was not pushing it right. Let me see. I think I should drop the application, not really well tested. Okay, yeah, that was the application. Capture. Let's wait for something more nice to see on the screen. And there you go.
Yeah.
Okay. And it is processing on the computer. And there you go. So I think it's interesting by that you can render the from RGB to HDMI, and also you can capture the images, and yeah, that's pretty much what I am building here. It's kind of fun to do it, and also that the people that is helping me with the testing of the project, I really appreciate that. And my final plan for this is, yes, to have something open source that is cheap and resolves the problem of having something to connect our retro computers. So that's basically the idea here. Let me see if I just missing something from the deck. Okay, so let me see some final thoughts. So as I said, $40 the Pico, only $4 the ADC. So if there is another member of the family, now it's the RP2040, which means 2 cores M0 processor and 260 kilobytes RAM. So if another member of the family with more RAMs appear, more density, more resolution. Right now, as I said, we completed the closed alpha. Now we are on the idea is that to have a do-it-yourself hardware beta, then open hardware. It's not a great mystery to reverse engineer a simple board, and then finally open source. That's the idea. So as I said, some of the bugs, the jitter when you enable the USB. Well, you will have aliasing on the borders if the resolution was pure Nyquist problem. If you have something with more resolution on the input and you are capturing with less sampling rate, or it will make make artifacts. And yes, there are some times that the levels of the image will, if there's a parts of noise or something like that, they can shift the gain of the ADC. That's something that we also have on the list of things to cover. That's not something that happens always. And it's simple. That's the thing. It's really simple architecture on the hardware. A lot of work on the firmware side. I mean, that's really much it. So I thank you, Sebastian, for the space to talk about this, and looking forward to make it available for everyone else.
Thanks very much. We will be following up that for sure. I don't know if there are any questions. I haven't seen any in the chat, but if anybody has a question, then please ask it now. If not, then I will just stop the recording. And if people have questions coming up, then they can put it in the chat and it can be answered while we start with the next call. Thanks again, Marcelo. So now we'll call then the next one, who's Daniel, with a nice little game, I guess.
Yeah, right.
Brainbreak. I don't know if you want to start sharing your screen or something. I will start the recording. Yes, there you are.
Yeah, right. Okay, yes, so my name is Krajzewicz, and I was asked to talk a little bit about a game that I released this year. I tend to be fast and maybe not loud enough. If it's the case, please let me know. Just say it. Yeah, so hi. That's too bad. It's not. I suppose I have to switch to the other window, because it does not. Oh yeah, it does. Okay. So well, I have been in the scene in the 80s already and have made some demos and a game as well. Atta, maybe one of you know it. But yeah, you know, then I started to study computer science and have a family and things like that. So I was not contributing to the scene anymore until 2017, where I met some people at demo group and a demo party, and it was quite fun. So I started to do a little bit of things on the C64, and well, I had the whole time I had a finished game on my discs, and which was 30 years old, and now I decided to release it. So well, it's a Brainbreak. It's in principle it's a puzzle game, and I will not show much of it. Just let's say, I hope it does work. Does it work? So maybe
that's a video.
Yes.
That yes,
Okay.
yes. For the moment,
Right.
that's what you want.
So it's a puzzle game. You can well, that's the start screen. It's as said, I was in the demo scene, so that's why the game has some effects as well included. And yeah, I think the video shows it quite fast. So you have not let's say not a high score, in fact, because the game consists of like 100 levels, and what you have is a list of players, and each player can, let's say, choose his name and then continue to play the game at the level he has finished at last. So the idea was that you have maybe friends or something like that, and every one of them can continue from a certain level. Why? Because well, the game is let's say it's a puzzle game, and you have of course to think a little bit about what happens and how to solve each of the levels. So you can select your name, then you can select the level where you want to start at, and yeah, then the game shows up. So that's the first level. What you're doing basically is you have matrix of 20 x 20 stones, gems, and other things. And what you have to do is to replay what's shown on the rebuild what's shown on the right side in gray. You have to rebuild this pattern within the game simply by pushing stones. Yep. Sounds basic. It's a basic game, let's say, but it has some different special things. So it has a lot of different special stones, like arrows that change the direction of the stones, like gates which can be passed only in a certain direction, like gates which only pass stones or gems of a certain type. You have teleporters. You have something that destroys moving gems if a stone is pushed against it. Then you have something that eats things. You have switches, glue and things to glue, and morphers as well. And yeah, let's say what's really special about the game are the graphics, because the graphics are, let's say, using something that well, they are using sprite overlay, and what you can achieve with that is that you have a plain high-res field, let's say, or high-res graphics, and nonetheless you have two colors plus black in each of the 8.8 pixel fields, right? So you have really very colorful game in the end, which is, let's say, not what you can usually see on the C64. Yeah, well, it's used everywhere in the game. So let's say, I don't know whether we have maybe noticed how the text is faded in, but there sprite overlay is used as well in this shade box effect, which has 6 colors, let's say, and of course within the game. Yeah, I will say some more about it in a few minutes. Okay, so yes, as I said, it was written in 1992 to 1994, and I could save the sources, so I had the sources saved on a 1581, and could read them on the PC using certain tools. Meanwhile, it's not. I think it's meanwhile not no longer possible because the disks have changed on PCs, I suppose. So what I have to do is to use a very old laptop that still supports it. And so I had everything for building the game. I had sources in turbo assembler format. I had I had the graphics, the music. I had yeah, basically everything I needed. Just what I had to do is to export the sources because they were stored in a binary turbo assembler format, and then convert them to ASCII, and then well, yes, modern assemblers have slightly different notations in at some points, like how words are defined or bytes are defined, but it was quite straightforward just by replacing things, and then I could build them using the Acme assembler. Yeah, so and within some hours I had the game back, let's say, and could it recompile on a PC. Yeah, and well, back in the time it was I just were using PAL computers, but meanwhile, of course, it's, let's say, the number of people is shrinking, so I wanted to support other variants as well. So NTSC above all, and PAL-N as well. You know, there's some difference between the different formats, like PAL runs with 50 Hertz, NTSC with 60. And yeah, so that's, let's say, was one of the things that I changed now in the version that's currently available. First to find out, yeah, first I had to find, of course, find out what kind of computer it is, and I found some documentation on this on the web, and I'm using TWW's method for that. But then you can have, of course, to change the timing. So that's so the image below shows how it would look like if you are not switching the sprites, because what you have to do is to switch the sprites every 21 raster lines. You have to move them down by 21 pixels. That's uncomplicated. That can be done within, let's say, while the sprites are shown. But what you have to do really on an exact raster position is to switch the contents from, let's say, what was shown on top and to what shall be shown in the next 21 lines. So that's relatively, you know, you have to be exact. Let's say it's these are well-known methods, right? We all know raster bars. It's basically nothing else than that. Then changing the background color in each raster line. Just that you have to do it every 21 lines to move the sprites. And yeah, of course, it's let's say, because you are showing sprites, you have less time to do this. So that has to be, let's say, yeah, exact, or an exact position. What's shown on the right is basically, let's say, the main method that times the thing. So you have independence to the found VIC variant. You have certain tables that show you how long you have to wait between switching the sprites. And what's let's say is done as well within this method is is putting the animation on screen, because you have sprites on top, and what's below them is a bitmap, is an high-res bitmap. And so let's say setting an animation takes some time, because you have to copy 8 bytes every time. So that's why it's done in the middle of the screen. And yeah, I have managed it to let's say to time it for PAL and for the old and the new NTSC versions, but I haven't managed it to time it for PAL, and so it's not working on that systems. Yeah, of course I had to do many other things to make it run on different platforms. Simply because, as said, you have well, the repetition of drawing the screen is different, but the processor has still the same speed. So I wasn't capable to plot that many shade pops on an NTSC system. That has to be reduced, and yeah, as well, of course, the screens would flip faster between let's say the text and the effect and the high scores and things like that. So that has to be adapted as well. Of course, the music would be played faster on an NTSC system. What I have done now is to let's say to skip the music player routine every 6th frame. It does not make a difference to me, and the music speed is still the same as it should be should be. Yes, and I found a guy who because I'm usually working on emulators, but yes, I found a guy who could test the game on his own computer, and yeah, would like to thank him. Yeah, so okay, let's say coding was one part. Another issue was to release the game really to people, let's say, on a honest base. Sure, I could of course just supply a binary, but I wanted to make something nice. So at first I thought about the Kickstarter campaign, which did not work. The main comments why it did not work were, well, the price was too high. That was one thing. But first is the people argued that puzzle games are not liked that much. That was one thing. And some said that they were disappointed by prior campaigns for the C64 games, that the guys simply did not deliver what they wanted to deliver. Okay, now, well, but what I could gain by the Kickstarter campaign was the publisher, Psytronics, which who's now supporting physical copies, and I have contacted someone who could as well support cartridges. But it's, let's say, not scheduled yet. And yeah, well, nonetheless, we have as well decided to release a plain binary copy on itch.io this year. Yeah, and as I said, I wanted to make something nice, not just the game. The game was almost finished. What I as well wanted to do is to build a manual by myself, and as well the box of the game, or the title graphics of the game. So yeah, the manual is mainly, let's say, it's simply written in Word. It's nothing special, just that I wrote some scripts in Python which use the original graphics, and then built some graphics for the manual, like like the borders of the screen, for example. And what's also quite nice is that I found a tool which is capable to convert old C64 fonts to TTFF fonts. So let's say the headlines are written using the original font from the game, converted into TTF, and then, let's say, simply used in Word. That's quite nice. Yeah, and well, the box was fun for itself as well, simply because I had the idea how it could look like 30 years ago, but did not realize it by that time. And I had to redraw the logo, and I had a model of the brain, so could import that and render that, but had to work on the lightnings, for example. So that was quite an interesting thing to write something that renders lightnings. I think meanwhile I've seen better than that, but it's nonetheless quite nice. Yeah, there are some reviews. The reviews are relatively positive, like 75% on average. I would say I would rate the game a little bit higher, simply because it really has very nice graphics, I think, which are unique, let's say, on at least within this year. Yeah, what I like very much is that the game has been cracked. There's a crack by Laxity, which is even better than the original game, simply because they managed to include a packer for the levels, so the levels are compressed within the release. They have not released it. They it's, let's say, the release is just on the internet, but well, the information about the release is on the internet, but there's no download link. And yeah, I would like to contact them, but I'm currently not allowed to enter CSDB because I was too inactive for a too long time. I have to talk to them once again. Yeah, so well, what are the plans for the future? I'm trying to build a PC game, PC version of the game, which is still in the development due to lack of time. I would like to exchange levels if someone has built something new, but I by myself have no new levels as well. And yeah, I'm working on some libraries for building the levels on a PC and for solving them using some kind of an artificial intelligence. But yeah, that's in progress as well. And yeah, I do have some plans on further C64 projects, like a karaoke game. I know there's one, but I would like to have something built as a community project where people can simply add music and graphics and then make a let's say one song or something like that and contribute that to some releases, and of course make some demos and games as well. And I'm thinking about how to use this graphic format for further games as well. Yeah, I've used different tools for when rebuilding this game, Brainbreak. Like I said, this Read 81 by Michael Gurce, for reading the disk, Turbo Assembler, Petro-ASCII, different PC tools, right? Like GIMP, for example, Python, Pillow, and other things. Oh yeah, Charpad as well. It's a modern PC application for building the 64 graphics. Quite nice. Yeah, that's basically all. If you want to contact me, you can find the game on itch.io currently. I'm writing something about the C64 on my blog. And if you want to contact me, then here's my email address. That's all. Thanks.
Thanks very much, Daniel. That's really nice. I have actually one technical question that you did during the talk. So it was about the PAL, because also in the 80s we were using this PAL secam, and then I was wondering how would it work with an NTSC or something. But you did answer that. I will not ask where did you find a 3D model of a brain. That I will not ask. I don't want to know.
Yeah, no, it's I suppose it's some kind of a scientific or medical thing or something like that.
Exactly. Yeah, I like the idea of this community project, and I see that we have someone who likes as well the puzzle game there. So maybe that's a good idea. We can have like a hackathon and bring some people together for a weekend and start building some kind of game over the weekend. I don't know. I see one question here from Robert. Why did you decide to use the sprite overlay effect as opposed to just using a model like ECM, for example?
Sorry, I didn't get it.
Why did you decide to use the sprite overlay effect?
Yeah, because in ECM you wouldn't have I mean, you could combine two colors in one char, right? That's two. But you still wouldn't have the third color. So that's the point, right? So, and using this more complicated thing, you have basically three colors on one chart.
Okay, thank you. I see Wilfried wants to ask something. Wilfried, if you want to unmute yourself.
Yes, thank you. Thank you for the presentation. So quite interesting. I would be interested in, since you have the game double licensed kinda, so you sell it on itch.io, but you also have the box with Slytronic, right? So was it difficult to achieve this, or is this standard?
To achieve what?
You sell the game via itch.io and via Slytronic at the same time.
Well, that's something that Slytronic proposed, in fact, to release the game as a digital version on itch.io and in parallel to sell it via them.
Okay, so they have no problem with, because they assume that collectors anyway will go for the box.
Yeah, that's the point. Yeah.
Okay, great, thanks.
Okay.
Thank you. I don't see any more questions, but again, if there are any more questions, people can put it in the chat. Thanks a lot. Sorry, last one maybe. Why choose to write a puzzle game? Are they your favorite type of game? Okay, that will be the last question, I guess.
No, definitely not. But it's like 30 years ago, and that was the point, right? And at that time, such games were relatively new, and that's the reason why I wrote one.
Good. Thanks again, Daniel. Thanks a lot. I will stop the recording now. And then we have coming up next is Wilfried with Philipp. And I think you have some extra support in the attendees, because I see someone with the same family name as yours. Or maybe that's just a coincidence, I don't know. Wilfried, then the floor is yours. Just give me 1 second, I will start the recording here. So the floor is yours, Wilfried and Philipp. But then you need to unmute, at least one of you. Because now you're muted, Wilfried, and Philipp as well. Or is it just me? Did I lose the sound? Can someone confirm that you can still hear me?
So now I should be.
Yes, now we can hear you. Perfect. Thank you.
Great. And I think the slides are shared, right?
Absolutely, yes.
Yes, great. So welcome everyone. This is me together with Philipp today to share our experiences with making a new power adapter for the VIC-20. So basically the story is I got a VIC-20 from a friend, but without power supply. And first I thought I might be able to use just the power supply for the Commodore 64, because I knew that there are VIC-20s with a 7-pin DIN connector, and this is basically the same connector as the C64, and it's also possible to use the power supply of the C64s there. But actually there are 2 versions for the VIC-20 power supply, and the later revisions, they have the C64 version, or basically it's the other way around, so the VIC-20 came first, but they have already the newer version that also later was then used in the C64. But the earlier versions, they have a strange non-standard connector. So you see here these 2 prongs. So we just have these 2 pins and some kind of rectangular thing that has to go in there. And this is the so-called 2-pin connector, and that supplies 9-volt AC, so alternative current, and all necessary voltages are then generated on board by the VIC-20. So the bad news is I didn't have such a connector, and I didn't have such a power supply to power my newly acquired VIC-20. But the good news is that making an AC 9-volt power supply is not that complicated, because basically we just need a transformer and hook it up to the proper connectors. So for the transformer, I found a model that is able to supply close to 3 amps on the secondary side, which is what is needed for the VIC-20, especially when the VIC-20 is run with external hardware. And basically the case was then designed around this transformer, and also to make it look a little bit nicer, we also added a power switch with a LED that indicates if it is on or off on the primary side, which means if the switch is off, then you can be sure that no current is flowing through the transformer, no current is active. So the main work was designing a proper case. So the requirements were that the case should close well, so with not too many screws necessary. So because normally we would have like 2 or 4 screws for fixing the transformer in place. And then we would have another bunch of screws for closing the casing. And after doing some brainstorming and different design ideas, we came up with the idea to have something that shifts into each other, so that we would only have 2 screws that fix the transformer in place as well as close the casing well. So basically, the transformer is to be slided into a part that looks like this classic door stopper design we know from C64 or VIC-20. And then we have an L-shaped part that closes it. And you see here on the bottom, there are some of our early designs. And on the right side, this is already the rendered model, the rendered 3D model, also with some cooling ribs, which are more there for the fanciness, and some logo in it that should do what it was designed for. So here is a short video that shows how the parts fit together. So for the backside of the L, there are also some indentations. So it has to be slided over well. Now I got it, second trial. And now it's closed. It's still missing the screws, but it's already quite tight. So this part of the design worked well. So for the further parts, now I would hand over to Philipp.
I guess you need to unmute as well, Philipp.
Okay, yes, I'm now unmuted.
Yes.
We needed connectors to connect with the VIC-20, but this wasn't too easy. You cannot use the you cannot use a non-standard connector. You you cannot use this connector. We had to use a connector from Thingiverse, a 3D printed model, and this functioned perfectly. As we had to print a connector, and yes, this was on Thingiverse. As you cannot convert a standard Euro plug. The holes are just too small. Here you can see the wiring and the transformer. So you just need basically a transformer and this switch. And it was very easy. It's a very easy power adapter. It's very easy to make. Here you can see the finished power adapter. Here is the LED on the switch to look nicer. And we have a logo from the Vintage Computing Carinthia. The final test worked successfully. We built two power adapters. The right one is connected and it worked perfectly.
But the other one worked as well.
Yeah, the other one worked as well. Yeah, thank you. So to take away messages, feel free to use our models, rebuild or modify the design. And we uploaded the open SCAD source that you can you can modify the design. I uploaded it on Thingiverse. There you can download all files. And yes, thank you for your attention. Any questions?
Thanks very much. I don't have a question. I don't see question in the chat. I think it was quite straightforward. It's a nice. I like the nice little box that you can just. Indeed, you have the two parts that fit into one into the other. I think the assembling it is probably more easy than yeah, you know, this famous Swedish company that makes furniture. This is more easy. Thanks. I don't know if there are any questions in the chat. I'm looking again. I see no comments, just a very nice power adapter. If anybody has a question, then please ask it now. Otherwise, just thanks again. If some questions come, so they can be posted in the chat. I will just stop the recording. Many thanks again, Wilfried and Philipp. And then I will invite our last speaker today, Gurce. I don't know if I pronounced that correctly.
That's all right. Gurce.
Gurce. Yeah, thanks a lot.
Sorry, I'm here lying in bed because I've been up since 3 a.m. in the morning. So apologies for that.
No, thank you. Thank you for being so committed, I would say. I will start now the record.
Yep. Okay.
And the floor is yours if you like to share your screen or so.
Sure, it says you cannot share the screen while other participants share.
Yeah, I think Wilfried or Philipp, you need to stop sharing.
Okay. Just wait for them to unshare. I wasn't sure who was the last one to share. Wilfried or...
I think I'm still sharing, but I'm still looking for my button.
Oh, how to unshare.
I think I did it now.
Yes.
All right. Awesome.
Yeah, thank you for that.
Okay, now I have to remember how to share on my side. Okay, I'll share everything I can. And okay, hopefully you guys see everything. Maybe I'm able to hide this stuff. And yeah, so hi everyone. My name's Gurce Isikyildiz, and I just want to talk today about a game I wrote for the Mega 65 called Battle Sparrow. And I think the main interest here is that it was written purely in Basic 65 as an example of trying to make a 2D shooter there. So a little bit about me. First, I thought I'd play some background music. Initially, I thought I'd use an MP3, but then I thought maybe this is a good chance to actually use the Mega 65 to play the background music itself. And yeah, so this was just a basic program. And you can see all the strings are just defining different notes in the melody and in the bass line. And at the end, I'm just playing various strings. And so there you go, I've got some background. Hopefully you're getting that. Maybe I'll drop the volume down. So hopefully that sounds getting through. I hope.
Yes, we can hear it.
Good, okay. I was born in Australia in 1978. That's a picture of me. And Dad bought my Commodore 64 back in 1986. And he went to Walton's department store, which is bankrupt now, it doesn't exist anymore in Sydney. And he traded in his pocket calculator and got a $100 discount on the Commodore 64 because they had a trade-in offer if you have an old computer. Somehow he managed to convince the salesman that this pocket calculator was a computer too because it had a CPU inside it. And the salesman bought it. Anyway, I've loved my Commodore 64 ever since. Had a great time with it, programming, music, and doing assignments and all that sort of thing. So how I got involved with the Mega 65? My dad became terminally ill in 2016, and this forced me to join Facebook to get in touch with relatives overseas. And Facebook happened to auto-suggest that I might be interested in the Mega 65 project, and yes, I was interested in the Mega 65 project. But why was I interested? For me, it was to experience what might have been. Like in 1994, like the bankruptcy of Commodore really hit Dad and me very hard. Like we were very loyal and passionate about our Commodore 64. We've been with it for about a decade, and so it was very emotionally and mentally difficult for us to migrate to the PC world. And so this is my fond memories of the 1980s, and moving into very painful memories in the 90s. You know, all these IRQ conflicts and DMA conflicts. I found it a world of hell personally. So not very fond memories. So I always feel like if I could go back into the 90s and just restore things and make things happier for me as a Commodore 64 person. And for me, Mega 65 is the machine that is that time machine experience I've been looking for. So get rid of all these painful memories I have of those eras and replace them with something pleasant where I'll be much happier. And so upon learning about this Mega 65 project, open source, volunteers can do whatever they want to help. Yeah, I had chipped in over the years, some bug fixing, some tooling. There was a Mega 65 remote debugger I wrote. There was an existing FTP tool, which I helped to stabilize for Windows and Mac and added some improvements on top of it. Some other interesting improvements were at the time, the long file name support added into the FTP tool for your SD cards. And also more fun for me was the play command inside BASIC to make that non-blocking and so that you could have music playing in the background of your games. Also worked on the documentation, manual contributions and some proofreading as well. And yeah, if you're interested in reading our manuals, they're all freely available online. That's the URL, you need to grab them. But yeah, after years of doing these sort of contributions in my spare time, I thought, where to next? And I've honestly been itching to have fun with the machine because you know, all this behind the under the bonnet work is, yeah, you don't have that sort of fun with it. But all the same, if you're jumping the Mega 65, if you have a chance to help out with that under the bonnet stuff, yeah, please lend a hand wherever you can and definitely have your fun too. But whenever you can report bugs or make bug fixes, GitHub pull requests, they're always welcome. And same with documentation improvement. You see an issue with the documentation, you're welcome to raise it or fix it. And also support others in their journey. We've got a lot of people on Discord and forums that are answering questions and making YouTube walkthroughs, and that's been a wonderful for our community. You know, we've got a very considerate and helpful community. Anyway, I'm in the mood for fun now these days. So, why make a basic 65 game? I've got limited spare time, working, married, 3-year-old daughter now, so life is a bit hectic. And I thought basic 65 is a good fit for me. And sure, I won't get all those low-level speed wins of pure assembly, but I'm going to get that time-saving win of working at a higher-level language. And I also want to showcase what basic 65 is capable of. So why make Battle Sparrow? I had a few simple basic 65 games I made prior to this. One was Momo, so I can demonstrate that now. Just stop the play music and you can load Momo. And this was a simple game I made for my daughter at the time. It was just to help her learn how to press the numbers 1, 2, 3 on the keyboard. So yeah, very simple. I'll just stop the music there. You can see it's purely 100% assembly. So already you're seeing things that you normally wouldn't see in a Commodore 64 basic game, some background music, some, well, fairly good frame rate for simple animations and such. The second game was a game called Poopy, which I intended to be a sort of Popeye clone, but I never really had the time to finish it off. I drew a simple Popeye character in Petsky, and so some nice music in the background. And again, just here your Popeye character, avoid the dog poo and try and collect the love hearts from the cat. But yeah, very simple. And again, it's all pure basic. So it's, yeah. This time around, I just wanted to push myself a little harder after those efforts, but not too hard. So I thought about, what about like a Warhawk-like 2D shooter game? And something, again, that would have been impossible to do back in the C64 basic version 2, 1 megahertz. And it also showcased the sort of fun you could have with the play command as well. I had fun with those prior games as well. So yeah, time just to give you a little preview of what Battle Sparrow is like. Maybe I can just restart this for a sec. And Battle Sparrow. And there it is. I might have to switch to input to go to the cursor keys as joystick. I'll just run that. Okay, so you got some nice background music there. You've got some scrolly sort of animated text with a bit of a sine wave in there. You've got this star field going on in the background. So already there's a lot of activity for a basic game. So we can sort of load up the level. So yeah, moving your character, the star fields there. There's a sort of map coming into view. And there'll be some baddies coming on the screen. Shoot at the turrets. Shoot your baddies.
Yes, we don't hear you.
Yeah,
The volume
sorry.
is too high.
Okay. Does that help? If I turn the volume down that way? Still hear me? That's all right. Maybe I'll just that's all right. Maybe I'll just stop it. Because, anyway, I think you get the gist of it, really.
Yeah, we could, at least I couldn't hear you. The volume of the game was too high, so
sorry about
I
that.
could hear that you were mentioning something in the background, but
Yeah,
could not, at least I could not hear it.
that's all right. I mean, just you saw there was a lot happening for a basic game. There was a star field animating in the background. We had sort of moving title text, you know, with a sinusoidal pattern, not the sort of typical things you see in a Commodore 64 basic game. And you had some very nice background music as well. Some of the stats on the sort of effort involved to make something like that. I coded this across several evenings over 2 weeks or so, and it's 650 lines of code, about 200 for game logic, about 150 for the Petsky graphics, 100 for the drawing routines of those Petsky graphics, 50 lines of music code, 40 lines of initializing variables, and 25 lines for the title screen. So yeah, it's not a huge chunk of work there. Why did I choose Petsky art? Like simple graphics like that, because again, I've got limited spare time. It was nice to draw the artwork I needed for myself. And I also feel personally that Petsky art has a very beautiful aesthetic of its own. It's very minimalist. I kind of equate it to, you know, Neanderthal man drawing paintings with primitive tools onto cave walls or something like that. So it's very unique. Yes, it's very unique to Commodore itself. Only Commodore has Commodore Petsky characters. So whenever we see them, we always know it's from a sort of Commodore system. And yeah, I also want to inspire others like me with limited time that, you know, when you look at my sort of crappy Petsky graphics here, yeah, so, you know, that's all you need to make a game in Basic 65, really. And I wanted you to look at this and think, yeah, I could draw something like that too, and I'm sure you could. And I'm sure you could even push yourself even harder than me. I mean, this is as hard as I pushed trying to draw a Petsky sparrow. I'm pretty proud of myself as pushing myself harder. And yeah, I personally have strong childhood memories of doodling in Petsky art. Like these are my day one memories of owning a Commodore 64 or first week memories, learning how to use the keyboard, learning how to switch colors. And I always found that a lot of fun as a kid. And I imagine if kids of the modern age had the chance to see how easy it was to switch colors, put characters onto the screen, it's a different flavor of fun that I'm sure even they haven't experienced before. And also on the Mega 65, you've got more colors to play with now as well. You've got those original 16 colors from the keyboard, which I'm showing here. And also we've got 16 new colors, and you can switch between them with Control D for the defaults and Control A with the alternates, which you can see there. The community gave lots of funky names for these new colors as well, which was a lot of fun. And yeah, and was the music done in BASIC? Some people don't believe the music was done in BASIC, but yeah, yes, it was. It was pure the play command in BASIC. And just a sort of a quick overview of that, the play command is now non-blocking, so you can play 6 channels of polyphony at your disposal. That's bearing in mind that the Mega 65 has 4 SID chips emulated in the FPGA. So the 2 of them, SID1 and SID3, are used to create these 6 channels. And that music will play in the background of your game, which is nice and handy. And also Basic 65 sound command is also non-blocking. That command is usually used for sound effects. And you also have 6 channels of sound effects at your disposal too. And again, those are on 2 separate SIDs as well that aren't going to sort of interfere with those music SIDs too. And keep in mind, this arrangement is just for Basic 65. Like if you're an assembly coder that wants to code like 12 channels of music, yeah, you definitely, sorry, not, yeah, 12 channels. You can definitely do that in assembly, but Basic is hard coded for 6 channels play and 6 channels for sound effects. As an example of that, I can load this one up. Load music and sound effects. I'll run that. And this one will play 6 channels of music on the first 2 seats. And I can press 1, 2, 3, 4, 5, 6 on the keyboard to play some sound effects. Anyway, you get the idea behind that. So yeah, there's no blocking. Like in 64 days, some games you'd play a sound effect and 1 channel of the music would cut off. But yeah, in this era, that's not a problem anymore. I've kind of let go of the project. I had fun and probably not much time left. But if I was to come back to it, I'd consider maybe using 80 by 50 character mode. That might be fun. Put more characters on the screen. And maybe that might add some bottlenecks too. That might be too much payload for BASIC to handle. There might be some assembly routines needed to speed things up there. And also it might be fun one day to have some 4-player action. I recently built one of the hacks that Paul devised to get these sort of ProtoVision compatible DB9 ports that let you sort of plug in 2 extra joysticks. So I've tried these out with Dr. Wuro's 4-player games. They work fine there. But yeah, it might be a crazy idea to add like a 4-player 2D shooter one day. But yeah, but for anyone else that's interested in dabbling with the Mega 65, just some recommendations. You can give the Xemu emulator a try. That's available at this path. And sourcing the Mega 65 ROM for that emulator can be a bit tricky due to the licensing issues. But if you can source yourself a 65 ROM, you might find one on the internet. I didn't say that. You could patch it to become a Mega 65 ROM. And RetroCombs has some nice walkthrough videos with some advice on installing the emulator on macOS, Chromebook. And for Windows, it's similar. I think you can sort of gauge the steps from those earlier videos. And he's also got a video on how to patch that C65 ROM and turn it into a Mega 65 ROM. And also, you're welcome to browse that free PDF manual, which is about 1,200 pages now. So it's got a lot of detail at any level you like. And that's the URL for that. And you're also welcome to have a chat and ask questions on Forum 64 if you're more of a forum person, or if you like that live chat, you're welcome to join Discord as well. Anyway, that's all I've got to share, so enjoy it.
Thanks a lot. That was really a nice presentation. I think you said you had fun writing this game. I had fun watching this demo, and this poo, avoid the dog poo.
Oh, the dog poo.
I was not expecting that today, but I will look for it on itch.io. I don't know.
It's probably, yeah, it was a bit of fun. Probably a bit cheeky, but yeah, it was fun.
I don't know if there are any questions. Let's see. I enjoy your presentation. Thank you very much. Okay, I see many comments. Cool presentation. Yeah, the music, that's indeed really, really nice. And I think indeed the Mega 65 is really a nice platform for writing games. This Basic 65 is really a good combination of Basic and let's say, well, they introduced new functions in there that make it very easy to build something quite quickly compared to the version 2 or version 7. Yeah, I think there could be in the future a community of developers building more for the 65. Especially that this Xemu emulator is available.
Hope so.
Yeah. I don't know if there are any questions. Please ask it now. Apparently not. I will just stop then. Looking at the time, I think it's certainly time to close. You were the last speaker today, Gurce. Thanks really a lot to you, and of course to all the speakers. As you know, without I say it every time, but without speakers there is no event. So, so for the others, don't be shy. Don't hesitate to come and present your project for the participants. Thanks a lot again for attending. And yeah, get in touch to present your project if you have something even being developed, or if you need some I don't know, some support from other people, or if you want to open it to more people or whatever. Just don't hesitate to get in touch. And then next meeting will be sometime in December. I will announce the date, but it will be probably I think the 10 December, something like that. And very soon, so the coming days, I will then publish the individual recordings. So each of these talks have been recorded separately. That will be available on our YouTube channel. Either you search for Commodore Users Europe in YouTube, or you just browse videos.commodoreusers.eu. That's the same. And of course, the event that was streamed today live on Facebook should remain available from Facebook later on as well. So thanks a lot. Have a good evening or good day, and yeah, see you next time.
Thanks, Sebastian.
Thank you.
See you all.
Thank you all.
Thank you all.